The most crystal-clear image of Proxima b ever taken by the James Webb Space Telescope has just been released, revealing astounding information about this potentially habitable exoplanet. What mysteries does this far-off planet harbor? Can life exist there? Follow us as we investigate how the James Webb Space Telescope just announced the clearest image of Proxima b seen in history. We can see how galaxies formed by gazing back billions of years in the history of the universe. We could explore and investigate the farthest reaches of space with the James Webb Space Telescope, JWST. The JWST's infrared photos are unlike anything that has ever been seen by human eyes. Like a Snapchat filter on your phone, the telescope's skills are dependent on how it is used. Astronomers may explore the early cosmos using the James Webb Space Telescope and learn more about how galaxies, stars, and planets form by capturing a precise spectrum of light colors with the telescope's camera and filters. Researchers may examine the hues in those photographs. In addition to exploring the atmospheres of planets outside of our solar system, the JWST will look for signs of extraterrestrial life. Significant discoveries about the evolution of the cosmos have been made as a result of the JWST's unprecedented ability to peer back in time and space. For instance, the telescope allows astronomers to find more mass than was previously thought to be there in the cosmos, hidden away in a number of large galaxies. What is Proxima b then? Observers finally found evidence of a planet's very slight gravitational pull on its star in 2013, after years of research. Later given the designation Proxima b, the planet revolves around Proxima Centauri, given that it revolves around the second closest star system to us after the Sun. The discovery of this planet is remarkable since we are viewing the Alpha Centauri system as it was 4 years ago. Observation of it offers a window into the past. The Alpha Centauri system is around 4 light-years away from us. When it comes to fascinating astronomical discoveries, Proxima b definitely wins. This planet is one of the nearest exoplanets ever discovered, being only 25 light-years from Earth. But don't be tricked by the distance, the world of Proxima b is entirely distinct from our own. The planet is bigger because its mass is around 30% greater than Earth's. Don't be fooled though, a very brief 11.2 Earth days make up Proxima b's year. This is due to the planet's close orbit to Proxima Centauri, which is only 7.3 million kilometers away, less than 5% of the distance between Earth and the Sun. The James Webb Telescope just announced the clearest image of Proxima b seen in history. The star would appear as a dull red ball nearly 3 times the size of our Sun, and if the planet is in the habitable zone of its star, which it looks to be, it may have the appropriate circumstances to support liquid water. But before you pack your bags for an interstellar vacation, keep in mind that Proxima b is not a second Earth. For starters, it's possible that the planet and its star are tidally locked, which means that one side of the planet is constantly facing the star and the other is always in the dark. That is not a welcoming atmosphere for any prospective life forms, and any water that gets extremely close to the star will be boiled away by its intense rays. On the other side, a planet will not receive enough heat if it is too distant from its star, and all of its water will freeze. Proxima Centauri may not be as welcoming to life as we assumed. Despite possessing only 1/10 of the mass of the Sun, its small size brings its nuclear fusion cores significantly closer to the surface, resulting in chaotic and turbulent surface activity. For planets like Proxima b that orbit within the star's habitable zone, this activity results in extraordinarily strong magnetic fields that generate high-energy radiation and particle bursts. The precise magnetic field characteristics around Proxima Centauri were unknown to scientists up until this point. Despite some knowledge of the magnetic field conditions around nearby stars, we now have a better understanding of the star's solar wind and the terrible situation on Proxima b, thanks to a recent study employing high-resolution magnetic field maps. According to the findings, the planet receives nearly 1,000 times as much solar wind radiation as Earth, endangering any possible life with strong flares. In fact, the Proxima Centauri flare that occurred in April 2021 was 100 times more powerful than any flare that the Sun has ever produced. It's difficult to understand how life might endure such high radiation levels without appropriate housing. While the notion of a planet with habitable conditions around Proxima Centauri is intriguing, the reality seems to be very different. Humans have always been intrigued by the idea of coming across extraterrestrial life, and that intrigue reached new heights in late 2020 when a strange signal was found coming from the Alpha Centauri system. It's interesting that this signal reads at a frequency of 982.551. Some believe the signal may have been created by a constructed device, others continue to believe it could be evidence of intelligent life. It might not be as impossible as once believed to visit Proxima Centauri, the closest planet to our solar system, and come across extraterrestrial life. The breakthrough programs have been looking for ways to reduce travel time from centuries to just a few decades. Recent studies show how present technology may be able to solve the issue of speeding an object as its mass grows, especially when it reaches the rapid pace of light. Despite this, Alpha Centauri, the nearest star formation to Earth, would need approximately 6,000 years of transit time with modern technology, making it a terrifying journey. Starshot, a project aiming to reach Alpha Centauri, the star that is closest in the system to Earth, is exploring utilizing lasers to push a spacecraft there. The biggest difficulty, however, is the Earth's atmosphere, which influences incoming light and laser light, making it difficult to generate the necessary force to send a spaceship forward. The original author of the paper, Bandhu Tunga, advocates utilizing adaptive optics in reverse to get around this difficulty. Small lasers on satellites would monitor the impacts of the atmosphere in real time, enabling far more potent lasers on the ground to keep a sharp focus on the space mission. The massive 100 gigawatts of power needed by the necessary lasers to transport the vessel at any given time is comparable to the entire electricity used in the United States. The lasers only need to operate at full power for 10 minutes. They intend to employ 100 million lasers to disperse the electricity over an area of 1 kilometer in size. The Starshot crew is committed to advancing space exploration. When the lasers are turned off, the object hurtling through space will be traveling at an astounding 20% of the speed of light. It would take just 22 years for this spaceship, which has a diameter of just over 10 meters, to go to Alpha Centauri. However, the Sun's gravitational force, plus that of nearby interstellar material, may cause it to move far more slowly. Even if the spacecraft makes it to Alpha Centauri, it will take another 4 years for its signals to get to Earth. One of the hardest problems, as Bandhu and Sybil are aware, is keeping the probe from melting. The mirror on the spaceship needs to reflect 99.99% of the light that strikes it in order to avoid this in a matter of days. It also needs to reduce heat while doubling momentum transmission. The probe would travel across the Alpha Centauri system after being launched, probably never reaching very close to a planet. The intriguing aspect of this idea is that additional probes can be added at a reasonable cost once the launch system is established. Click on the subscribe button if you are finding this video interesting. If a fleet of probes floods nearby star systems, the chances of obtaining a momentary sight of any Earth-like planet are greatly increased. Think of the opportunities mankind would have, a whole star system to explore after they reached Proxima Centauri. How many more planets like our own are possible? There have already been countless discoveries of exoplanets, which are planets outside of our solar system.